So, welcome everyone to the first presentation of the 25-26 season from the Civils Division. My name is Joe Seymour. I'm the chair of the Civil Division with Engineers Ireland, and we're delighted to be joined here today by Uisce Éireann, some of the representatives who've worked on the Arklow Wastewater Treatment Plant, and they'll give us a good insights into that project over the next few minutes. So before we do that, though, I will just mention that it's the Civil Division. We're trying to keep as active as we always do, with a presentation every month throughout the year. But the next presentation will be the 23rd of October, and we would like to do this one in person in Clyde Road. It'll be on the Bus Connects project, an update on the Bus Connects project, and it'll be followed by the important networking opportunities in Cafe Clyde afterwards. So it'd be great if we can get people there to that event in next month. But back to today's event. So we're going to give an overview of the planning and design and construction phases of the Arklow Wastewater Treatment Plant, where we have four speakers here: Michael Tinsley, Senior Portfolio Manager with Uisce Éireann; Paul Fallon, Portfolio Manager with Uisce Éireann; Conor Delaney, Portfolio Manager with Uisce Éireann; and Dr. Ronan Royston of Ward and Burke and Construction. All have significant experience in delivering these types of projects, and hopefully we get some really good insights into this fairly significant project, 130 million project that's been delivered over the last while. We all know how important getting how wastewater and many of the other infrastructure things are for our housing crisis that we're underway at the moment. So it is good to see these projects getting completed and allowing other projects to proceed. So I'm going to hand you over to Michael Tinsley, who will lead on the presentation. So thank you very much.
Thanks, Joe, and thanks to Engineers Ireland for having us today. So yeah, I'm here to talk about the Arklow Wastewater Treatment Plant, and yeah, if we flick onto the next slide there, we're going to be like one of those movies where we kind of have the ending, and then we're going to explain over the next 2 hours or 3 hours how we get there. So this is the official opening of Arklow down on the 9th of May with the Taoiseach and the Minister and the Takahirlock there. It was a great day. We had the national media. I'd never been at one of these events with the Taoiseach before, and it kind of brings it up an extra level. He did a kind of an impromptu press conference for about 45 minutes. It was pretty interesting to see. So look, if we move on, we're going to start with a video. And kind of shows how unusual Arklow is as wastewater treatment plant, how in terms of how well it looks, and probably kind of going to explain why it looks that way. So I suppose just to put it in context, Arklow is the 38th largest town in the country. I think it's a little bit bigger than Castlebar, a little bit smaller than Mallow, but it kind of had the inauspicious title of being the largest town in the country without a wastewater treatment plant, and because of that, it was one of the agglomerations where the ECJ prosecuted Ireland for failure to comply with the Urban Wastewater Treatment Directive. It's also on every naughty list that the EPA have, including the untreated list and the priority action list. And probably to kind of tie into what Joe said, there's really been no development in Arklow for the last 20 years because there was no wastewater treatment plant. So Uisce Éireann or Wicklow County Council before then couldn't give people connections into the sewage network, because there is a sewage network in the town, but prior to the completion of this scheme, it outfalled in 19 different locations along the Avoca River. I suppose I mentioned it being one of the locations around the country where there was no wastewater treatment. So when Uisce Éireann came into being in 2014, there was actually 50 locations around the country, mainly coastal, but a couple of inland where wastewater was being discharged from the public network untreated into rivers, lakes, and seas. We've made really, really good progress on those 50. Arklow was actually the 35th of the 50 that finished, and we've all the large ones done now. We've 4 more that are due to finish later this year, 2 up in Donegal and Ramelton and Mullen, and 2 down in Cork in Whitegate and Ballycotton. We have a few more under construction, a few more about to start construction, but we do have 2 or 3 of them that are tied up in kind of litigation and kind of challenge, which is unfortunately a feature of some of these projects. But yeah, like we are committed to getting them all done, and we've spent over 650 million euros to address those issues. And as Joe mentioned, the Arklow project was a 139 million euros, and thankfully we've managed to deliver it on budget and 6 months ahead of schedule in terms of the construction contract. So I'll just kind of move on and give a little bit of history about Arklow. So if we could just flick on the slides there. Um, yeah. So yeah, I don't know how well this has come across, but this is from the Irish Times in 1972. And it basically lists all the locations around the country where sewage was being pumped into the sea, which was almost the entire country back in 1972. And if you look really carefully down the bottom right-hand corner, it says Arklow, no treatment, new scheme planned. So there was a new scheme planned in 1972, which was actually before I was born, I can say that. So just about. So we move on to the next slide. So yeah, there's a long history in Arklow. The original planning application was made in 1993 and approved by Bord Pleanála in 1994, but that didn't go ahead for a number of reasons. So a revised planning application was made in 1999. That was subject to so much legal challenge at the time that Bord Pleanála didn't actually grant the permission until 2005. And after 2005, there was more and more legal challenges. There was a High Court case and a Supreme Court case. And basically these were from Arklow Holidays, which was a caravan park or mobile home park, which was about 2 kilometers north of the town, beside where the treatment plant was going to be built. All the legal challenges were unsuccessful. I worked in Wicklow County Council before I joined Uisce Éireann, and I remember sitting in the court, at the Supreme Court hearing, and it was kind of crazy. But what actually happened was, because the legal cases went on for so long, the planning permission expired. So it was a 10-year permission in 2005. When our Uisce Éireann came along in 2014, there was ongoing legal challenges around the CPO. So it was at that stage we decided to start again. And I suppose I got a chance to kind of start. It was a project I inherited when I was in Wicklow County Council, and I got a chance to start it again. And maybe just flick on briefly to next slide. Yeah, I suppose just to kind of make this more about me than Arklow. When I was in college in 1995 doing my master's, we did a module on environmental impact assessment, which was brand new at that stage. And I found this a few years ago in my parents' attic when I was cleaning it out. I wrote a paper in 1995 on the Arklow Wastewater Treatment Plant, saying the plant was going to be built in 1998. So I think I got a good mark for the paper, but I think in retrospect that was I probably shouldn't have. So when we started in Uisce Éireann, we said, right, we have to get it right this time. We have to get a scheme that's acceptable to the town, and we have to kind of work our way through. Now in Uisce Éireann, we have all kinds of procedures and methodologies and MCAs and all kinds of things and CBAs for deciding on projects. But back in 2014, we didn't have anything. We were a brand new organization. So what we did is we looked around and we said, oh, look, they've done that site selection for the new Dublin wastewater treatment plant, the Greater Dublin Drainage, which still isn't built. We'll follow their methodology, which was a 4-step methodology. We kind of simplified it because we didn't have to show the need for the project because the sewage was already going into the river. So what we did was we followed a 2-step process. One, which was a preliminary screening where we looked at the kind of parcels of land available around the town, and kind of pipeline corridors. And that gave us kind of a long list of 10, which we brought down to a short list of 3. And then we had a public consultation around that. And if you slip onto the next slide, so we got that 3, and then we looked at a very detailed kind of MCA approach, and we took the 3 down to 1. What was really interesting about the public consultation was that during the first public consultation, we asked people to challenge us on any of the assumptions we made, and they did, and new information became available through that public consultation, which actually made us go and redo the first phase and get a different answer. And I think by doing that and people seeing that we did that, it gave us a lot of credibility. And I know when we finally got to the end, and if we flick onto the next slide with our preferred site, I remember getting an email into the consultation address, which basically said, I wouldn't necessarily pick the site you did, but I can't disagree with your process because you were so transparent in it. And I think that was really, really nice to hear. But basically we chose a site kind of right at the mouth of the river, which was it was originally a fertilizer site, and then it was an old derelict gypsum wallboard factory. And the reason, kind of to simplify it, the reason why that site came out at the top was because all the sewage could get there by gravity. And it also had the advantage that it was a brownfield site, so we were going to be able to kind of rehabilitate it, and we weren't going to impacting on a greenfield site. And also we were very close to the sea for a marine discharge. So effectively, and we probably touch on it during the design, there's only one pumping station in the entire process, which is, you know, kind of very sustainable, and kind of looking at the long term. So yeah, so that was kind of towards the end of 2015, beginning of 2016. We had kind of taken about 2 years to do this consultation site selection process. So at that stage, then we kind of moved into the detailed design. So we move on to the next slide. So yeah, look, this is an overview of really what the scheme is. So you can see the wastewater treatment plant site there in the orange with the marine outfall, but probably as important is the fact that all the sewage was going in. If you think of each of the sewers was going in kind of perpendicular to the river. So we had to intercept those 19 sewers on the south and the north side, and then kind of tunnel underneath the river and connect it all up by gravity into the wastewater treatment plant. So yeah, so I suppose kind of flick on to the next slide. So yeah, like this is effectively the scheme is a wastewater treatment plant using sequencing batch reactor technology, and I suppose yeah, the plant is built for 36,000, but we've only fitted out now for 24,000. We can expand that at a later date. Like I said, yeah, we have a long sea outfall, 900 meters, and then kind of interceptor sewers at either side. Probably one thing that we overlooked in the site selection and caused us a little bit of, I suppose, kind of a pause to rethink was the upgrading of the rock armor. That probably more visible on the next slide. Yeah, so this rock armor was built in I think after, what was it called, Hurricane Charlie in 1986. And I suppose we never considered it during the preliminary design that might have to be upgraded. But as soon as we got into the detailed design, the RFs, who were the engineers at the time, came back and said, guys, you're in trouble here. This needs to be significantly bigger. So we actually paused the design for a number of months and kind of looked at it to see if we needed to change our approach. But yeah, look, I suppose the rest of the slide here is just a summary of the northern interceptor sewer is 900 meters and the southern interceptor sewer is 1.1 kilometer. They're about 1.2 meter in diameter, and then there's a crossing underneath the river. There's also a flood relief scheme has been planned for quite a while between the OPW and Wicklow County Council, and we had to kind of we made sure that everything we were building was aligned to what they were doing. Probably just kind of one or two more slides for me. Yeah, so I mentioned the rock armor revetment, so that needed to be significantly bigger than was there. So that was kind of 2 meter high, 500 meters in length. And then, yeah, we kind of knew going into it that the site, it had quite a history of, kind of use for chemical and other uses. So we knew it was going to be quite contaminated, but we found all kinds of interesting things like gun cotton when we did the site investigation. And it also transpired that the factory, the building, was the second largest asbestos-containing building in the country. So that became, I suppose, a big part of getting the site ready for the wastewater treatment plant. And then, yeah, look, then I suppose at this stage we were getting into the EIA and all the things that we would need to assess for an EIA. And probably one of the big things that came out from our consultations with An Bord Pleanála and Wicklow County Council was that the land we were going to build on the wastewater treatment plant on was zoned for waterfront, which was kind of for mixed use, commercial, residential. So any building we built there was going to have to be, kind of, I suppose, a good neighbor and kind of visually of a high quality. So it was at that stage we kind of brought the architects in Clancy Moore Architects came in under ARPS to work with us on the appointment. So I'm going to hand over now to my colleague Paul Fallon, who's going to take us through the kind of planning and procurement.
Thanks, Michael. So just in relation to this slide here and the detailed design and the EIA, we've listed some of the main impacts that had to be assessed and mitigated. Just to reiterate what Michael said, just to highlight a couple of them. the management of the construction traffic and transport of materials in and out of the site was critical due to the restricted location of the site, bounded by the River Key on one side and the Irish Sea on the other. Mitigation of nuisance impacts from noise, dust, odor, or vibration were key also due to the necessity to undertake works such as interceptor sewer tunnel shafts in close proximity to residential properties. The historic 19 Arches Bridge is the only bridge crossing in the town, and we had to bring a sewer under the bridge, and we had to underpin a number of the bridge arches to protect this historic structure. Michael mentioned the interaction with the OPW flood scheme. This is quite important as well. We had to align our design so that when the OPW flood scheme does come to construction, they won't have to move any of our sewers, and the section of piled quay wall that we installed, they can use that for the flood protection works. So just to move on to the next slide then, in terms of public consultation, again, I think Michael mentioned earlier, when Uisce Éireann were formed in 2014, we're very well aware of the long, difficult history with the Arklow Wastewater project, so we're keen to start afresh with a blank page and ensure we had the robust public engagement. So we had the 3 periods of non-statutory consultation from 2014 to 2017 as part of the site selection process. We had the 2 information days, many leaflet drops, press releases, and we received over 200 submissions, which were all considered by the project team. So on to the next slide then. So in terms of the public consultation as part of the SID, so the planning process for this scheme came under the Strategic Infrastructure Development of the Planning and Development Act. So we had a statutory 7-week consultation period commenced in September 2018. The planning application plus all the appendices and documents were published on the dedicated project website. Notices were published in newspapers, and site notices were erected in the town. And we received 14 submissions via On Board Pleanála in relation to this statutory consultation. So just move on there. The oral hearing then took place to address those submissions. The planning process, there was also a need to acquire land for the project, and the compulsory purchase order was necessary to acquire all the land and the whaley rights for the project, and this was lodged in parallel with the planning application to a board pleanála for approval. So the oral hearing then was necessary to be held as a result of the submissions, and it was called by On Board Pleanála, and it was held in January 2019 over 3 days, and both planning and the CPO were approved then in August 2019. So as I said, there was a number of submissions at the oral hearing, and just to touch on briefly some of those, there was a number of supermarkets close to the site, and they were concerned about impacts on their businesses during construction. There was homeowners and apartment groups that were also concerned about noise and vibration and traffic impacts during construction. And some of the issues that were agreed at this time, a contentious tunnel shaft was removed by design and sewer realignment. A commitment was given to temporarily relocate some residents closest to high impact construction works, and the use of a temporary access road was included to limit traffic disruption during construction. If you just move on there. Yeah. So just briefly to touch on procurement, our agreed strategy was to procure as a single DBO contract, design, build and operate contract under the Uisce Éireann major MICA framework. We had considered splitting it up into smaller discrete elements, but the conclusion was that a single contract was preferred on a risk basis. The contract form that we used was the FIDIC Gold with standard Uisce Éireann amendments. However, we did make a number of inclusions specifically for Arklow. An advance payment clause of 10% was included. And in hindsight, given that the works commenced in 2021, which we all remember was a period of very high inflation, this advance payment allowed the contractor, Burke, to advance purchase in bulk many elements, including steel reinforcement and similar, to allow them to progress quickly. And also the fixing of the electricity rate meant that Uisce Éireann retained inflation risk on the electricity at this time of high energy inflation. Just on the right of the slide there, just show the timeline. So we had pre-tender briefings, expressions of interest in November 18, and invitation to tender in July 19. I suppose the main point of interest, just to highlight here, we had the interim technical submissions. So this is a mechanism where we ask tenderers to submit interim design submissions on methodology and design, so that we could give a view on anything to ensure that all designs were compliant and to avoid any wasted design and tender work. And we believe this worked quite successfully. Tenders were submitted and they were assessed and closed out by September 2020. So just to touch briefly on governance, it's not the most exciting element of it, but certainly it's necessary for us all. So we followed the internal Uisce Éireann governance process that was in place in 2020, budget and contract approval, and our board approval in November 2020 for a capital budget of 143 million, and the award for contract to Response Engineering, Warden Burke at the time. We had an external approval process to New Era, National Treasury Management Agency, and the department that was lodged in December. And in parallel, then we had the updated public spending code required a final business case to be prepared for the project. And that was submitted in May 21, and formal approval from the department then was the following July 2021. So finally, before we get on to the construction element, an important decision that we made while we were waiting for the approval from the department, we agreed to engage with Warden Burke and issued them a letter of intent to proceed with design works. So this allowed them in the period from March to July to proceed with a lot of advanced design works and survey works. And so this allowed them to commence really quickly when the contract was awarded in August 21. And I believe it facilitated the early completion of the project within programme. So I'll hand over to Conor now to take you through some of the construction elements.
Thanks, Paul. I'm just going to give you a brief overview of, I suppose, the main construction elements of the project, and then I'll hand you over to Ronan Royston. He's just going to get into one or two technical detailed elements of the project in a bit more detail. There's lots of these, but we don't really have time to cover them all, so he's just going to give you a flavour as to the type of engineering, I suppose, Warden Burke we're working on. So just project scope, that's more or less been covered, but the main thing was we're bringing approximately 2 kilometers of sewers from the town of Arklow into the new site, and a new wastewater treatment plant with an ultimate capacity of 36,000 p, and then a new long sea outfall up to there, approximately 927 meters. And then the revetment upgrade there, you can see the photo of it on the right, that was necessary as well to protect the site from coastal flooding. If you move on there. The Warden Burke, we heard about Warden Burke there, Paul, in his procurement element. We also procured an employer's representative. So they were called Burn Newby at the time, but now they've rebranded to Uisce. They acted as the ER for the entire construction phase of the project, and we also had a team of resident engineers from Nicholas O'Dwyer. That's just a high-level kind of Gantt chart of the main activities on the project. I put this slide up to kind of try and give you a flavour of the amount of work fronts we had on the project. You can see there at the top we're working on kind of shaft construction. We were also tunnelling at the same time. We were working on the flood defence, the bridge rehab, also on the open cut pipelines, and up at the CSO site as well. And then on the main site we were building in a pump station, working on storm tanks, SPR. So all concurrently, all these activities are happening concurrently. So there was a big resource requirement on the site, and it had to be well coordinated. So I'm going to touch briefly on the network upgrades, and then touch on the treatment plant. So this is a kind of quick summary of basically the works we had to do. There's 19 untreated outfalls into the Volca River. So we had to pick all of them up. So each of the shaft locations there is for the interceptor points. So some of them were needed for as tunneling, launch and reception shafts. Others were just put in there so that we could pick up outfalls. So if you move on there, so that's the extent of the tunneling we did. So all along the North Quay, around the marina, across the river, and up to halfway up the South Quay. So Ronan is going to touch on that in a bit more detail, so I won't go on into any more detail on that. The rest of the works was along the South Quay. So there's two sections there. Essentially, there's a section south of the bridge, where what we did is we reclaimed approximately 6 meters of land from the Volca River, and constructed our pipe in that section. It's a 1200 pipe in that section, and that was constructed in open cut fashion. We then had a bridge crossing. I'll touch on that with a few photos, and then upstream of that, everything was open cut, relatively quiet roads, and smaller diameters, so a little bit more straightforward than the rest of it. So I'll show you a few photos now of the. So this is a section of the works where we were reclaiming land from the Volca River. So you can see on the right hand side our kind of sheet pile wall there. So again, that was, I suppose, probably one of the most intrusive activities we had on the site for the local population. You can see the cottages very close by. So again, we had to manage that very carefully. There were structural surveys done of all of these properties. Now these were actually in pretty good condition, but it is hard to convince local residents that there's no issues when you're talking to them about the piling being safe, and the cutlery is shaking in the background. So, but every effort was made to reassure them, and structural surveys confirmed at the end of the project that there was no issues. So if we move on to the next photo there, I'll touch briefly on the bridge works. So you can see there in the photo on the right, I think Paul mentioned it briefly. So we had to bring a pipe across this 19-arch bridge in Arklow. So this is the only bridge in Arklow, in the town of Arklow. So obviously very risky work, and it's an old structure. So we were going to take up so essentially what we had to do is we had to reinforce the abutments of the bridge. You can see that there, the photo to the right. So we did that first, and once we had that done, we were able to. What you ended up doing, Warren Burke ended up doing, is a kind of what they describe as a kind of caveman tunneling pipe thing. They put in a sleeve, and then they were able to excavate through that. So that was well managed again, and that was a high risk piece of work. That's kind of a quick flavor of the treatment plant, of the network works. Again, it's all gravity, and it comes into the treatment plant. And I'll show you a bit of information there on the treatment plant next. So if you go to the next slide. So the first task I suppose we had was basically prepare the site for the construction works and demolish the existing structures, and remove the contaminated land, upper layer of soil from the site. So the next photo there gives you a good flavor of it there. So it's you can see there the demolition work. So that was again was complex piece of work, but it was well managed by Warren Burke's subcontractor Tinsley's, I believe. And that piece of work essentially took about 4 to 6 months, and it allowed us to get started on our main works. So this photo here is about a year later. That's the inlet pumping station that you can see there. So Ronan is going to go into a bit of detail on that. But you can see the dry well on the right, wet well on the right hand side, dry well on the left hand side, and then the short sea outfall. So that's an emergency overflow out into the Irish Sea. And on the left hand side of the picture, you can see that's the storm tanks when they're constructing the storm tanks. On the next photo there, that's around the same time. You can see at the same time as we're working on these items, we're working on the construction of the SBR tanks on the left-hand side of the site. So you can see there 2 tanks are under water test, and we're still constructing the other. So all these things kind of happening concurrently I suppose was necessary to meet our program demands. The next photo there, that's probably 6 to 9 months later. You can see the revetment there on the left, so that was nearly complete there. Again, the photo probably doesn't do it justice when you're standing beside it. It's quite a structure, and I suppose one of the beneficial things we did there was a lot of the rock armor for the revetment was actually brought to the site from the Arklow quarry via boat and discharged onto the quay. So that helped us save a lot of traffic through the town of Arklow. So just on the photo there, you can see the inlet pumping station there at the front of the photo. So from there, the water is pumped up to the inlet works. So there's a couple of screens, grit removal, and a flow distribution chamber. From that point, it either flows into the storm tanks or across to the SBRs for a secondary treatment. And you can see the picket fence thickeners there as well, being constructed. They were done precast. Next photo there is about a year later. So at this stage, I suppose the entire process was probably close to up and running. All M&E fit out would have been done. And then they started building the superstructure, I suppose, for the architectural elements. So that kind of gives you a flavor of it there. Again, it was a completely different piece of work and had to be managed very carefully by the contractor. If we move on now to the next photo. Okay, that's just I suppose a good graphic showing basically how the water flows. So as Michael alluded to, the entire network flows by gravity into the wet well, and from there it's pumped through the system. It's the only time it's pumped, so it's I suppose relatively efficient design. Pumped through the screens, the grit lanes, flow distribution chamber, and across to the SBRs. There are storm pumps as well. They're not, I suppose, that they discharge directly to the short sea outfall in the event where the 500 liters a second foul pumps are beaten. On the next slide, then we move over to the SBR system. So it's treated in kind of 4 phases: fill, aerate, decant, and empty. So there's 6 cells here. Only 4 of them have been kitted out for the moment, and we have an allowance for future expansion with 2 more. They kind of run in cycles, and they end up in the decant chamber, and from there they go out towards the long sea outfall. So I'll touch on that in a second as well. And then quickly on sludge. So the waste activated sludge is pumped out of the SBRs back into 2 picket fence thickeners. From there, it's thickened and brought across to centrifuges in the inlet building, where it's dewatered and taken away off-site in sludge skips. So I think the next slide is on the long sea outfall. So this in itself was an interesting project on its own. So it's constructed 927 meter outfall pipe. It was actually manufactured in Norway in 3 sections. You can see there the photo that's a photo when the 3 sections of pipe arrived from Norway. So they're essentially pulled in the back of a boat all the way over from Norway through the North Sea. The pipe is a 630 mm diameter pipe, and it was installed 1.5 meter below the seabed, and 6 diffusers with 4 risers on each of them were installed at the end of the pipe. Located approximately 13 meters below, I suppose, the water surface. Few more photos there. So the pipe, once it arrived in Arklow, was prepared by so Warren Burke had a marine subcontractor, Van Ord. So they're kind of experts in this area. So they prepared a pipe in Arklow over a couple of months, fitting it with these concrete collars, supposed to add weight to the pipe. And once they were all all these concrete collars were installed. The pipes were welded together, and they were floated out to sea. You'd see there the photo of the dredger there. So that dredger was used to build a trench for the entire length of the pipe. So that's the connection point on land there. So on the next photo there, you'll see the that's the morning the pipe was sunk. So it all happened in one morning, I suppose. So once the pipe was ready, it was pulled out by the boats, connected to the dredger, put into place by the various tugboats, and then it was filled with water from the land connection, and it just sank under its own weight. Obviously, very carefully managed by our marine contractor. And once that was done, I suppose U-shaped collars were added to add an extra ballast to the pipe. The trench was reinstated by the dredger, and they were essentially gone off site by the end of the summer. So all that activity happened over one summer, the summer of 2022. So briefly again, I'll touch on stakeholder engagement. There was, I suppose, a lot of work happening in a number of locations in Arklow. And I suppose we felt it was very important to engage with the community. So we had a full-time community liaison officer employed by Ronan Burke with a dedicated phone line, and we had weekly communications with local reps and elected reps as well, in person and online. So that was a very important aspect of the project, and it helped us kind of manage I suppose the public, but in general, the public in Arklow was generally supportive of the project. So it was a great help, and they all contributed to the success of the project. Quickly on the, I suppose, completion of the project. So all outfalls to the river were diverted into the new interceptor sewers in July last year. And the SBR tanks were seeded then from Uisce Éireann Wastewater Treatment Plant and put into operation in August 2024. And the contractual 90-day test period began in September and concluded just after Christmas last year in January 25. So the project officially completed approximately 6 months ahead of program and is now in a 7-year operate contract. Just quickly on safety, we had only one LTI on the project. It was a minor ankle injury. Someone stepping off a ladder and at the bottom of a shaft. Thankfully, it wasn't anything too serious. There was a couple other high potential incidents at the start of the project. Nothing, not too many of them, but they were addressed, I suppose, very quickly. Mainly kind of cable strikes and kind of working near water. So they were. We worked with Warren Burke on that, and thankfully we didn't have any more safety issues. And just in terms of the final account, it has been agreed with Warren Burke in shortly in advance of completion, and the project has been completed within the originally approved budget, which I suppose was a challenge during the inflationary time that the project was completed. And there's been a few kind of design tweaks as well to the design. So I'll hand you over now to Ronan. He's going to run through a couple of items in a bit more detail there. Thank you.
Right, thanks, Conor. Yeah, so I'm from Warren Burke Construction, so we're the design and build contractor on this. So I'm going to sort of flesh out some of the construction challenges I suppose we had and how we overcame them. As Conor said, you can see that there's a variance of challenges across this project. I'm going to just look at two elements, which is probably the tunneling and the shaft sinking. So most of our work was carried out underwater here. We're close to existing services and buildings. So in order to reduce potential ground movement, everything, all the shafts were constructed underwater in the wet. So I'll touch on that. And not all the pipelines, but a lot of the pipelines were constructed using trenchless technology, using microtunnels. So yeah, the benefits of that, you have minimal footprint across the town. We're not digging up the streets, etc. In order to do it. So the tunnels were generally 1.2 meters to 1.5 meters in diameter. So comfortable enough to walk down. So just to touch on the tunneling process, So on the right here is a sort of a pictorial that we have for the tunneling setup at ground level and what's required. On the left here is a picture from one of the sites in Arklow. So this is at the top of the town on the northern side of the river, where we launched here and did a 430-meter drive, I think, 400-meter drive up the North Quay. So our shaft was here, and I suppose while it's quite small, footprint of a 1.2-meter pipe, this is the equipment that's needed with it in terms of the separation plant to strip out the slurry water that comes back, the driving container, crane, tunnel delivery, etc. So I won't get too much into the theory of it, of how the slurry works, but it kind of gives a feel for the size and the constraints. So it's quite a tight site. They seem to be getting tighter and tighter as we go, but so you have to be kind of fluid in how you make these work. Just on, I suppose, the caisson construction / the tunneling process. So just for anyone who doesn't know what micro tunneling is, it's a trenchless technology where a fluid is pumped to the face. The head turns relatively slowly, brings back a mixture of the fluid and soil back to be separated at ground level while the TBM pushes forward. So everything's pushed forward from inside in a shaft with a jacking frame. TBM is pushed into the ground and then followed by a string of concrete pipes. So precast concrete pipes, which we design and build up in Fermanagh and deliver to wherever they're needed. And then they're pushed into the ground, let's say below the water table. You have fully dry excavation. You're not playing around with reducing water level and settlement, etc. So minimal disruption. So pipe is dropped in, jacked forward, pipe jacked in, dropped forward, etc. until you have your full pipe string. So this is a picture inside of one of our tunnel pipes with all the electrics. Obviously, this is a big power drawer. So you have all the electrics within, your lights above, your slurry feed lines, which is your bentonite slurry feed lines and return lines, and various lubrication lines. So just a little bit on the theory. What we're trying to do with the face is we're pumping a bentonite slurry to the face to balance the hydrostatic and soil loads at the front of the TBM. As we push the string forward, we're generating friction along the TBM plus the pipe. As you go further, that's all transferred axial load through the pipe and through the TBM. You're jacking forward with a series of hydraulic jacks in your shaft, back into your shaft wall and resisted by the ground outside. So it's a fairly involved system. On top of the structural and the geotechnical side, you have the mechanical side of pumping fairly viscous fluid, along with your electrical requirements, your torque requirements, your TBM, etc., and the general challenges that come with work underground of this nature. So it's just a quick overview of the tunneling process and how it works and how we did the drive. So there's a couple of one drive under the river and up the street, as I say, close, tight to buildings, existing services, etc. So the shafts and tunnels were challenging. So we were, I suppose, a little bit feel on the ground is a predominantly sandy material in Arklow, almost like a beach sand throughout the town nearly. So high permeable ground. So water was the big challenge. It's a tidal area. So you had a tidal range of, not a massive tidal range in Arklow compared to other areas, but about 1 meter to 1.5 meters. So you're dealing with trying to manage the tides on the work you're doing as well. So this is our 3D model of the treatment plant. The area I'm going to talk about in, I suppose, a little bit more detail is the inlet pump station, which Conor touched on earlier. So this was a 19-meter diameter shaft, 19 meters deep, and it was 20 meters from the Irish Sea. And again, so it's quite a large shaft. Because of high permeable ground, we structured as an underwater caisson, 1.6 meter wide reinforced concrete walls. So the weight of the wall provided the downward cartilage to sink the shaft to formation. And a crane was used to excavate within the shaft to sink it down. So you can see in the time-lapse video here over the couple of months of sinking, adding the pores, striking the formwork, excavating to move it down slowly into the ground to get to our formation level. So I suppose a really challenging piece of work in terms of managing that soil structure interaction on the outside to manage friction, and just the management of how we were going to dig it, how we were going to control it, and get it to formation safely and accurately. So I'll touch a little bit more on them details. So if I kind of break this down step by step, Here's a simple cross section of, say, ground with water table at the top. We put a few sheet piles around the perimeter of the caisson and dug down into the ground about 3 meters, and then we started building up our caisson. So at the bottom of our caisson, we had a tapered edge. So the idea of this was to reduce the bearing capacity of the ground beneath the caisson to allow it to sink. And on the outside, then we had a small steel overcut. So as we sink through the ground, we can fill that with a bentonite lubricant and reduce the soil structural friction effects and sink the caisson shaft down into the ground. We excavated the first about 2 meters in the dry with a few submersible pumps to keep the water out, and excavated to get for the caisson, I suppose, to find its path in the ground. So again, as I said, we're typically looking at a failure mechanism beneath the footing like this, reducing friction on the outside. So friction on the outside, we're pumping in large quantities of bentonite to limit that, and we're excavating at the footing to remove the soil, reduce the bearing capacity, and sink the caisson down into the ground. Once we got below a certain level, and our pumps were beyond the incoming water was too much for the pumps, which is about another 2 or 3 meters down. We took the machine out of the excavation. You can see it here being lifted out, and we moved to a wet excavation. So the whole caisson was allowed to flood with groundwater, which is the tidal water, so we moved to wet. So again, just a little bit on the theory, I suppose, of excavating in the wet. So you can do it with an excavator, or because the diameter and the depth of this was so big, we had to use a crane mounted clamshell. So this is just a video of it working. So it works on 2 falls of the crane to lift the clamshell, and you can open and close the clamshell with it. So you can see it's quite a sandy material. The water drains out, crane slugs around and empties out the load that's picked up below, and repeats this again and again. So we were getting about, I think we clocked on average about every 3 minutes we were taking about 1.75 meters cubed of material at the base of the excavation to allow it to sink into the ground. Obviously, all this is blind from what's happening on the floor of the shaft to how the caisson is moving. So we actually built our own leveling system with the University of Limerick and the University of Oxford, cast in a series of pressure transducers around the caisson to tell you where exactly the caisson was lying in space as we sank into the ground. So we had a simple red green for high and low, and this was transmitted back in real time to the crane driver, who was the man who was making the real calls in real time. Moving on to that, we had the caisson. We knew exactly where it was in space and how we were sinking it. The next unknown for us was the ground profile below. So we were trying to figure out what was the best way to do this, and we recall back our fishing days when we were younger, and we went on to Amazon and bought a few sonar measures. We put it on our fishing rod, and we had the app, and there's Laura and Eve would go across the shaft at predefined locations and measure how far it was from water to ground at regular intervals. So very unusual to see anybody out on site with a fishing rod over a shaft. So we did this every day at each of the break times, at tea time at 11 and at lunchtime at 2. And we'd a bit of a script written that would output the data then into a picture format. So a heat diagram basically of high and low. So green being where the ground is high and red being low. And when the crane driver came back from his tea, this was sitting in front of him on the dashboard, so he could see what the ground was looking at. So now we knew where the shaft was. Was there a point where he was getting caught on, and he could see, right, I need to excavate in around here to get this shaft moving again. So a very useful tool as we move through. I suppose very, very simple too in a lot of ways. So typically he kept the middle high, and outside the cut and shoe low. So he was bringing the soil out to the outside to excavate the shaft and sink it into the ground. So then we were adding our pores as shown in the video and sinking the caisson down into the ground. So at this point we had we hit our desired formation level. We had a shaft with 70 or 80 meters of water in front of us. So you can see it there, just a full of water, and our shaft to formation level. Our concern is when you go through, there's layers of cohesive material. You potentially have cohesive material along the face where our concrete plug is going to be, where I'll touch in a second. We typically bring in divers to inspect, go into the shaft and inspect all the way around the perimeter at the base of the excavation, see if there's any clay, see what our formation is like, and give us sort of the all clear. So it's what we use a lot, from big shafts to small shafts, as we go. So once that was complete, we were able to move on to pouring our underwater tremie plug. So tremie concrete is a form of is underwater, pouring underwater concrete. The way we do it is we use tremie pipes. So it's basically a series of hoppers at the top down to the very bottom of the excavation, and we fill into the concrete hoppers up. So we had our theoretical underside of plug, theoretical top of plug, which was 3.6 meters. We started filling 6 o'clock in the morning, one very rainy morning, similar to the one today. Brought all the tremie pipes up to level and started filling one by one with a series of hydraulic rams on the tremie pipes to lift them up out of the ground, out of the concrete. So the concrete that was set was towards the bottom, lift them up to get our full concrete plug. So that was about 3.6 meters of concrete, which is quite a lot of concrete to get that seal. So you're 90 meters deep, so you're almost 2 bar of pressure at the base of the shaft. So substantial pressure along with the 19-meter span that the unreinforced concrete plug had to resist in the permanent case, which I'll show. So all them tremies were taken out that evening. We got the plug poured. Shaft was pumped out 5 days later to leave your excavated formation. So just to take a small step back to our tremie pipes and our I suppose how many we had and why we did it. So this was a lot of thought on our side of what was the best way to lay this out, how we're going to do it, how to make it as robust. We felt we were robust in our thinking, how we were going to, probably one of the most important aspects of this whole scheme was to get this tremie plug right. So what we did, we built three truss bridges basically to span the 19 meters across the shaft. And we put in 8 tremie pipes. So 1, 2, 3, 4, 5, 6, 7, 8, kind of evenly distributed across the shaft. So you can see it here that we did some slump tests on our underwater mix, how it was going to work, how it was going to flow, looking on the literature and how it all worked. So this was kind of our crossover diagram of each of the tremies. We were trying to get it as even as distribution as we could, designed our bridges to suit that, and went from there. And then again, that's kind of going from planning of a few sketches to the reality of how we're doing it. So these were all hydraulically powered, so you could lift them up and down with a simple lever to control your levels. Just a couple of statistics from the pour, I suppose. So our idea was, because it was such a large volume of concrete, it was almost 1,200 cubes of concrete. We wanted to get in as quick as we possibly could, so it didn't set on us underwater, and we get a cold joint, or you get water leakage in our permanent case leaking through our formation. So we started at 6 o'clock in the morning. So we started as early as possible to beat as much traffic as we could in the early rush and get around the lorries in at us. Finished at 2:30, so about eight and a half hours of pouring concrete. We're averaging around 137 cubes per hour of a pour, which is the equivalent of one truck being offloaded every 2.5 minutes. So really quick turnaround in terms of managing the traffic management, and different things. So we were drawing concrete from 4 different concrete plants along the East Coast, and we 3 concrete pumps onto it. So managing this from a logistical point of view, and also the technical point of view of which tremie pipe do you want to put the concrete into, how long is it set for, etc. So we had a 10-foot container beside the shaft with power to it. We had 2 engineers inside in the container, and there were 2 walkie-talkies. So every time a concrete truck was offloaded, it was rated on 8 cubes into tremie 4, 8 cubes into tremie 2, etc. So we knew exactly how much concrete had gone into each tremie, and it was spitting out in real time into, I suppose, a spreadsheet that we could jump in and have a look at. So why this was important from bringing your design through to construction is we could see what the flow rate was like, how much concrete we were pouring at all times. So we see here we were up at around 180 cubes of concrete per hour at one stage. We dropped down with one of the pumps, kind of we had issues with one of the pumps, so it dropped down. I suppose the important part of this is Royston was our supplier, and they had their technical guy in that office too. And he was saying, right, 180 cubes at the moment, they've dropped down to 120. Send less less. They have to batch an hour beforehand. There was an hour travel from the Blessington plant, so he could slow down the rate of his concrete pump, his concrete deliveries to match our what we were pumping in. So what that meant was you had less concrete sitting in trucks, and you also had less traffic and backup throughout the town. We had another crew going around based of student QSs, health and safety engineers, pulled off, and they were constantly dipping the excavation of what level the concrete was at. So basically a rope with a tape, and they were radioing that back into the control container into Laura. She'd input it into it, so everything was labeled, and we could see in real time what the level of the concrete was at each location to make sure that it was perfectly level. We're hitting the right level at all time. So again, bringing the chaos, I suppose organized confusion, as we call it sometimes, the chaos of 3 concrete pumps pumping underwater, completely blind, and sort of giving you a bit of a visual, more technical aspect to it. You can see the concrete lorries backed up, so they were offloading every 2.5 minutes. We had a system in place that the trucks coming from further from the Blessington plant, they basically had a red sticker on their windscreen, so they jumped to the front of the queue. So we were offloading the oldest concrete as quick as we could in order to get in and make this a success. So just I suppose a picture at the bottom of the final output when we pumped it out the following week. So this is pumped out. So you can see it was actually bone dry. So I suppose extremely successful from our point of view to pour this, get it completely dry the following week. And you see there's just a lot of silt and stuff being scraped up, machined down the bottom the following week. We hadn't even got the last truss off just yet. So again, I suppose wanted to delve into the details. We had the fine buildings up top down to the underground stuff of how we actually built it. So fantastic project. So I think I can say for all of us, if any questions, give us a shout there, and we can run through them if we've time.
Before we start that, can I just say what an impressive project, and the amount of engineering that's gone in here is absolutely fascinating. Unfortunately, like all civil engineering, it's all hidden in the ground and nobody knows it's there. But it is a seriously impressive project. We've